So, good afternoon, sir. So my tackle is all about block shear strength, and this my example is a bolting plumb joint, and this is the bolting plumb joint is bolt. The bolt are 20 mm in diameter in 23 mm holes. The plates are 12 mm and the thick 12 mm thick is of 1 or the trinket. Here we find x of 1 equals 23 mm, is of 2 is equals to 76 mm, is of 3 equals 50 mm. The allowable stress of plates, tension and gross area is 0.60 Fy. Tension in net area equals 0.50 Fu, or unit tensile strength of plate. Shear. Wait.
Study hard here.
Choy. Yields ultimate tensile strength of plate if you yield strength of plate Fy equals 248 MPe. So this is the drawing. This is top view and this side view, and the question is find the safe load P based on gross area yielding. So first of all, we need to find the given. So x of 1, x of 2, and x of 3 is given from the question. And the plate thickness T equals 12 mm, and the bolt diameter was 20 mm, and hole diameter is 23 mm. So first of all, we need to find the gross width or WG. To find this is we need to find the gross width. This is x sub 3 and x sub 3, so plus 2x sub 3 and 2x sub 2. So this multiply so that we can get the gross width. So 2x sub 3 plus 2x sub 2 equals, so we know that x sub 1 x sub 3 equals 50. So 2 times 50 plus 2 and x sub 2 equals to 76 equals calculator. Two times 50 plus 2 times 76 equals, so 252 mm. So now we get the gross width. So next step is find the gross area or EG. Gross area. So gross area equals to WG or gross width times the thickness of the plate, so equals, gross width is 252 times the thickness P is 12 mm equals 252 times 12 equals 3024 mm squared. So next is to P. But so we have the gross area and the gross width, so we can now find the P. P load, so 0.6 Fy times EG, or gross area. So P equals 0.6 times an Fy is 248 times EG is 3024. So P equals to 0.6 times 248 times 3024, 3024 plus, so 449,971.2, that is Newton. To convert to kN, so or 449.97 Newton dito, or run up equals to 450 kilonewton. That is the safe load P based on gross area yielding for 50. And number two question is find the safe load P based on the net area rupture. So first, like before, we need to find the net width. Before is gross width, and now is we need to find the net width. So net width, or WN, equals to gross width minus summation of holes. So there are, so we know that WG, or gross width, is 252. So minus summation of holes is 3. So 3 negative, minus 3 times 23, minus 3 times 23, so equals 252 minus 353 plus equals 83 183 mm. So next is we need to find the net area. Earlier is gross area and now is net area. Net area, or in AN, so equals AN equals to WN, or gross width minus thickness times thickness, so equals 183, or W8, this is with net, I mean, is net with. So 183 minus 183 times 12, I mean, times 12 equals 183 times 12 equals 2,196. 2,196 ang net width area, the net width area meter squared. So to find P, P is equals to 0.5 FU or FU is ultimate tensile strength of plate. So times 400 or 400 siya liter. So net area to times net area. So P equals 0.5 times 400 times net area equals to 2,196. So equals 0.0. Sorry for that. 0.5 times 400 times 2196. 2196 equals 4 equals P equals 439,200. This is Newton. So convert this to or 439.2 kilo Newton. So now we have the P. So this is the safe load P based on net area rupture, 439.2 kilonewton. So the next question is, so find the, so P equals to 439.2. So this is the safe load P based on net area rupture. Next is find the safe load P based on block shear, on block shear. So first we need to locate the path. So our path 1 is from here, there. So throwing the path 1 is from here, and then that is our path 1, and this is except 1, except 2, then here except 2, sub 2. So our except 1 equals to 33 mm, except 2 equals 76 mm, and except 3 equals to 50 mm. So we'll find the net tensile area. Net tensile tensile area or EV. EV, that's not Y, it's V. So EV. Need to locate the or EV or shear, net tensile shear. So this is our tensile here. So from the drawing here is 2x. So 2x 2 times summation of 2x. So 2 2x sub 3 2x sub 2 2x sub 2 times x sub 1, then minus 2.5. This is given, this is constant. 2x sub 2.5 d times dh or whole diameter times the thickness. So EV equals 2x summation, and our x sub 2 equals 76, and a sub 1 is 33 times 33 minus 2.5 times r whole is 23 times thickness 12. So 2 times 2 76 33 minus 2.5 33 12 equals 2. So EV or net tensile area, that's the one, is 3060 mm squared. That is our net tensile area. So next is to find the net shearing area or AT. Equals 2x sub 2 minus 2 dh or whole diameter times thickness. So summation 2 times 76 minus 2, and dh is 23 is 12. Summation 2 times 76 minus 2 times 23 times 12 was 1272. So 80 equals to 1272. meter squared, mm squared. So next is the P. Find the P. The P is P equals 0.5 and ultimate tensile strength 0.5 times ultimate tensile strength of the plate. So yeah, times the area plus 0.3 times shear net shearing area plus 0.3 if you times area on net tensile area, so equals 0.5 at RFU is 400 times 80 equal to 1272 plus 0.3 times 400 times EV is 3060. So P equals 0.5 times 400 times 1272 plus 0.3 times 400 times 3060 equals 621,600 Newton, or 2 kilonewton is 621.6 kilonewton. That is our part 1. This is our part 1. So next is part 2. Part 2. So our part 2 is only here. This are the bolts. Here is our part 2. Here is part 2. This is sub 1, sub 2, sub 2, sub 2, sub 2, sub 3. So AV equals, okay, we didn't have here, so we just ended up here, so we didn't have 2 times, so 2x sub 2, so there's only 2 here, times e sub 1 minus 2.5 dh times the thickness of this plate. So 2x times 76, or a sub 2 equals 76 times e sub 1 equals e sub 1 is 33. E sub 1 times 33 minus 33, 2.5, or our dh is 23. So and thickness is 12. So our net tensile area is 2 56 times 3, 3 minus 2.5, 23. Sweet. So it equals to 1530 squared. The next is net shearing area, or ET. So 2 sub 2 plus sub 3 here, sub 3 minus 2.5 times 23 times the thickness 12. So it equals to, calculator, 76 plus 50 minus 2.5 times 23 times 2, 1070 1734 squared. So I need, next is P. So P here, the force P is 0.5 Fu times plus 0.3 Fu times EV. So 0.5 times 400 times 8. 8 is 1734 plus 0.3 times 400 Fu 400 times EV. EV is 1530 mm squared. So P equals 2. So P equals to 530,400 Newton, or 530.4 kilonewton. So this is our final answer. Answer to the part 2, but in the question, is find the safe load P based on block shear. So the lesser the loads is, the more the safe. So part 1 is, so the part 1 is more, I mean the part 1 is 621.6 and the part 2 is 530. So it means the lesser the weight, the lesser the loads, it's better or safer. So 530 is less, so 530 is safe. So So the answer is 530, and that's also, oh, I mean, that is the sample one.